Alright, so moving on to question number 5, we're being told to find the integral of x log x base 10 dx. So this is another example of a number that actually will require us to use integration by parts. So what I'm going to do in this question, so this is what we have. So let's first consider that x log x base 10. So let's do something about it. So as you can already see that this value here, so we're going to actually express it. So we're going to try to convert this log, we're going to convert this in terms of ln. But remember that a ln is actually a log to the base e. Now log x to the base 10 can be expressed as log x base e divided by log 10 base e. So it's exactly similar to that. But remember that log x to the base e is actually ln x, and then log 10 to the base e is actually like ln 10. So that's what we have right there. So now we basically have x ln x over ln 10. So this is now how it looks in a more simplified version. So x log x base 10 dx shall be equal to the integral of x ln x over ln 10 dx. But in this case, we can already see that 1 over ln 10 is actually a constant, so you can actually pull that out of the integral, and then in the integral we'll be left with x ln x dx. Alright, so now that means we're going to apply integration by parts for this side of the integral. So what happens is we're also going to have to be wise with our selection. So I wouldn't want us to take a long process. We're going to let u to be the ln x, and we're going to let dv dx to be equal to x. So that's going to be a wise decision, because doing it otherwise would actually make the process more complicated or actually impossible. So we always make u to be actually equal to the version that is more complicated to actually work on. So we're going to let dv dx to be equal to x in this case. So now definitely here the derivative of u shall be equal to du dx shall be equal to 1 over x, and then from here to find v shall be equal to the integral of this x dx, and then v shall be equal to x squared over 2, as you can already see. Therefore, integrating by parts, in the formula we're going to substitute in the values. Now remember that we already have this constant on the outside of the integral, so we'll actually have to remember that. So we're going to have this constant on the outside, then we're going to put all the rest inside a bracket. So it's going to be 1 over ln 10 into bracket. Now our u value, so our uv values are, so remember we let u to be ln x, and then this was the value we got for v, so it's x squared over 2 times ln x minus the integral of, now here we have x squared over 2, which was the value of the v that we got, times now du dx was actually 1 over x, then dx right there. So as you can already see, this and this reduce, and we'll be left with the integral of x over 2 right here. Then here we'll have x squared over 2 ln x, and then this is what we have right there. But now we can see from here that actually you can pull out a half from this integral, and then we'll be left with having to find the integral of x, which is actually easy to work on. So therefore we'll have 1 over ln 10 into a half x squared ln x minus, as you can already see here that the integral of x is actually x squared over 2, of which that a half that we get from it can multiply this a half, and that's why we have a quarter. So we have a quarter x squared plus c, and this is our final answer.